Hello everybody. This is our second video on types of error. Today we're going to talk about systematic error, right? So what you need to be able to do from this video is you need to understand what is a systematic error and be able to sort it out as different from a random error, which was in the last video. And we're going to look at how systematic error ruins accuracy, whereas random error ruined precision, all right? So you have to be able to sort those two things out, all right? Systematic error is associated with accuracy, while random error is associated with ruining precision. Okay. Let's start with a question that just kind of comes up every day. Here's our essential question at the top. Are measuring mistakes correctable? So if you make a measuring mistake, can it be corrected? We saw in the last video that sometimes if you have a bad ruler, which has no lines on it, you can't really figure out where your mistake came from. It has to do with your guessing and your estimation, and because there weren't many lines, you can't go out and do a calculation and figure out exactly where your error was if you just had that one wrong side of the ruler, that bad side with no lines. But so that's not a correctable mistake. Random errors are not correctable. We don't know where they came from. By definition, they are random. They can be greater than or less than our real value. However, systematic errors we're going to look at, we all know some errors are correctable. That's a systematic error, okay? They're always correctable. They're either up or down, not both at when you're doing the same measurement, right? All right, so let's look at we have a short ruler demonstration this time. So this is another demonstration I kind of do with the class, but I'm not here, so I'll explain it to you. We're going to take the same baseball bat, right? But this time, the idea with this demonstration is, and I'm not going to use the four-sided ruler here, let's just use a normal meter stick. We're going to measure it, right? And each group, there's 4 groups, each with 6 students in it usually, and each group would get this baseball bat and have each student in each group, so all 24 students, measure the baseball bat. However, one of the groups is given a short ruler. I've chopped off 10 centimeters of one of the rulers. And you know what, you guys, I gotta say, I don't know what you would do, but I know previous classes have not even noticed. They just go ahead, they measure it, and they're like, why is my measurement so much different? Well, because your ruler is 10 centimeters shorter than all the other rulers. So the idea is like the first 3 groups, you know, they're not getting the exact same measurement because there's always random error present. So you can see group 1 is, even within that group, you have some discrepancies. You know, you have different estimations, right? All within a small range because it's still pretty precise, right? This is a pretty precise measuring tool. There's lots of lines, little guessing, little random error, right? Very precise. So group 1, their highest measurement was 0.865 and their lowest was 0.862. Pretty precise, small range, right? Group 2, same idea. Group 3, same idea, but the short ruler, as you can see, was given to group 4. Yeah, I hope you noticed that. How do we know that? Because all their measurements are 0.1 meters, or rather 10 centimeters, different than all the other groups, right? So you could see each group's average, who didn't get the short ruler, is very close to the real length of the bat, but the group that did get the short ruler, their average measurement is 10 centimeters shorter than the real length of the bat. Okay, so when we look back at this, can we look at group 4 and say they made a random error? No. There was nothing random about not noticing that there was, you know, that they started basically their measurement at the 10 centimeter mark, you know, because that's where the ruler started. There's nothing random about that. Once I show them the ruler and I say, you started it at the 10 centimeter mark, they say, oh, okay, so what am I going to do to fix this? What am I going to do? Come on, It's very simple. What could they do to fix their measurement? It's an identifiable mistake. It's not random. All their measurements were off to one side. That's a systematic error, not a random error, right? It's not like they got a 0.7 and then a 0.9. That would be like imprecise, very random and spread out. The random errors go both ways and create a spread in precision. But this isn't imprecise, right? This is very precise. How do we know it's very precise? Because the measurements are very consistent, just like every other measurement, right? The measurements are very consistent. So they're all precise. Small range for all of them. They're all precise. But this one is not accurate. Its average measurement is not centered around the real value. Its measurements are centered, or they're off center. All right? So what we say is when the accuracy is ruined, there was a correctable mistake made because all the measurements are off by the same exact amount, right? In this case, that was 10 centimeters. So what are they going to do to fix their measurement? Well, all systematic errors are correctable. They're correctable
Debbie, please call the office.
By a calculation. What calculation are they going to do to fix their measurement? Yeah, they're going to add 10 centimeters to their measurement. Once you could identify your mistake, you can correct your mistake, right? Are random errors correctable by a calculation? No, because we don't know where they came from, right? Can we say that that the small spread here that was due to random error, that we could say, the 0.764 should be just a hair lower, right? That was an estimation, We can't go back and figure out why that person estimated this a hair too high, but we could figure out why they're all 10 centimeters off. And the consistency of this error is what makes it systematic. It follows a pattern. It's a system, right? And it ruins the average measurement, right? That's a systematic error. It's associated with accuracy. Okay. Kind of ran through that. Let's see if I missed anything. Don't think so. So how have you seen a systematic error which ruins the accuracy of measurements in real life? Where have you seen this before? If you go to the supermarket, a lot of times, you may even work there, you do self-checkout. At the self-checkout counter, right, maybe you're buying onions, right? And you have the onions, and you have them in, let's go something lighter than onions. How about, I like jalapeno peppers. They're pretty light. You put them put maybe 1, 2 in a bag, and you put them on the scale. But you're paying like maybe $1 a pound, whatever it is, for the jalapenos, right? They're pretty cheap. I'm weighing not just the jalapenos on the scale. I'm weighing what they're contained in the bag, right? So am I paying for the bag? Yeah, I'm weighing it, so I'm kind of paying for it too. Is the bag very heavy? Well, no, but compared to the jalapenos, it still has some weight. So the weight of the bag, every time you weigh the jalapenos, you're getting a measurement that's a little bit off from the exact weight of the jalapenos, right? From the real, say, weight, right? Is this a random error? No, we know where it came from. It came from the weight of the bag, and it's always off in one direction. It's not off up and down. It came from the weight of the bag. And is it correctable? Of course it's correctable. How are you going to correct it? Subtract what? The weight of the bag, right? Certainly your measurements will be precise at the supermarket. Every time you put the jalapenos on, you're going to get a repeatable, consistent measurement with a low range. But the weight of the bag is a systematic error. you could either remove the bag or just subtract it out. But it ruins our average measurement, right? I mean, we might be weighing like with the bag 1.1 pounds, 1.1, 1.1, right? When the actual weight is 1, 1, 1, 1. So our average of 1.1 pounds would be off from the real weight of the jalapenos, which is 1 pound, right? Systematic errors ruin accuracy. They skew the average measurement and center it around a new value.